Welcome back. We left off the last video asking the question, how do we improve this score and what if Ridge wasn't working? And then we kind of referred back to our machine learning map here. What I might do is put this link in here. Go, let's refer back to the map. Link there, and I might put it up here. Step 1, check the scikit-learn machine learning map. Now you can find this pretty easily, right, by searching scikit-learn machine learning map. Now what we're getting here, remember how right at the very start we talked about how we're getting focused on just writing machine learning code, deciphering what problem we're working on, and then finding the right model for it and applying that model. That's exactly what we've just done here. We've discovered what our problem is, we've imported our data set, and we want to use these characteristics about different towns and cities to figure out the average house price. And so that's what we've done. We've deciphered our problem, gone to the machine learning map and gone, hey, we're going to go follow this through. And now we found ridge regression because we answered a few questions to get us to here. And we figured, well, that's not working, so we might try something else. And that's where we get upon to ensemble regressors. Let's click on that and see what it says. Ensemble methods. The goal of ensemble methods is to combine the predictions of several base estimators built on with a given learning algorithm in order to improve generalizability, that's a big word, / robustness, far out, I can't speak, over a single estimator. Now, what this means is it's essentially combining a whole bunch of smaller models. So imagine if we used 10 different ridge regression models and we combined them and asked them to score each other, and then we averaged that score. That's the premise of ensemble methods. And why am I talking about ensemble methods? Well, that's where random forests come from. Forest of randomized trees. And now, the reason why we go straight to randomized or randomized trees is because it's kind of like the war horse of machine learning, right? Random forests, you see it's got a classifier version and a random forest regressor. That's why we're focused on it. Almost no matter what structured data problem you have, and by structured data I mean things that you find in a data frame or a table, something that looks like this. If there are patterns between the features and labels, aka these columns and the target column, chances are a random forest will find them, at least somewhat. So that's why we're focusing on the random forest and ensemble methods. Now, how could we use an ensemble method? Well, from sklearn.ensemble, import random forest classifier, define x and y, instantiate the random forest classifier, and then fit it. That seems pretty straightforward. In fact, we've actually seen this, but let's see it for our particular problem. So we've tried the ridge regression model. Let's try the random forest. So how do we do this? We go from sklearn.ensemble, import random forest regressor. Then we're going to set up a random seed because we like our results to be reproducible. np.random seed, and we love the number 42. And we're going to go create the data. We could actually even just copy everything here, copy that, and do it again, but we're going to get in the habit of really getting used to this kind of setup. Could copy that, sub out ridge for random forest regressor, but we're not going to do that. We're going to write it out. So create the data, x equals Boston data dot drop, and we're going to remove the target, axis equals 1, wonderful, y equals, oh no, this is Boston df, wrong name. Boston df, we want to use the target column here, wonderful. Split the data, x train, x test, y train, y test equals train test split, x, y, test size equals 0.2. Beautiful, exactly the same code as above. And then we're going to go instantiate random forest regressor, and we're going to call it model equals, or maybe we'll call it something else just so we can quickly compare it. RF equals random, oh no, we need a capital R. Can we do tab autocomplete? random forest regressor. Yes, we can. Wonderful. And we're going to go rf.fit. RF stands short for random forest, right? I've just made that up. Y-train. And then we want to go evaluate the random forest regressor. That makes sense. Beautiful. So RF Y test. Is that correct? Before we even run it, what do you think will happen here? So does it look kind of similar to this? Well, in fact, it does. It is. I kind of gave that away before, but let's run it. If in doubt, run the code. We get this little warning here because, again, in the future, if you're using 0.22 or scikit-learn 0.22 or above, n estimators, which is a hyperparameter here, is going to be set to 100, so we can remove that warning by setting n estimators to 100. 8.873. Now, what did our ridge get? 0.666. Wow, that could be an omen. Nah, I'm kidding. Let me go model.score just so we can see them side by side. Maybe we'll put a little comment here so we know what's going on. Check the ridge model again. X test, Y test. And we know they're using the same splits here because we've set up a NumPy random seed. So we'll go model.score. So on the same data, right? We could even comment this out in this cell just to be sure. Well, comment it out. Oh, that's even done better there. And you know why that will change even though we've got a random seed? It's because there's some sort of randomness within random forest regressor, hence random forest. It means it's randomly creating models every time you run it. And so if we did this again, so just by using a different model, we improved our score by 0.22, about that. So 0.22, but you can clearly see that this number is bigger than this number. And that's all from just defining what our problem was and then paying attention to our machine learning map. So this is kind of what you want to do at the start of every machine learning problem or project that you're working on, is figure out what kind of problem that you're trying to work on. Is it regression? Are you trying to predict a number? Is it classification? Are you trying to predict whether something is one thing or another? Is it clustering? Or is it dimensionality reduction? So once you sort of know what problem you're working with, then you can follow the steps in this flowchart and figure out which scikit-learn estimator or aka machine learning model you can use. So what we're going to do next, that's an example of working it for a regression problem. You can probably try this ahead of time if you want to be a daredevil like that. Is see if you can choose which estimator you should use for a classification problem. Start here, go through here, use the heart disease dataset we've been working for, heartdisease.csv, and see if you can figure out which one it is. Or you could kind of just scroll up and see the code we've written before. But let's set that up. 2.2, this can be choosing an estimator for, it's a classification problem. And we'll remind ourselves, let's go to the map. Excellent. So that's what we're going to cover in the next one. We've seen what it's like choosing one for a regression problem, and now we're going to see what it's like for a classification problem. I'll see you in the next video.